Welcome there, function folks. Lesson is 1.11 on solving polynomial inequalities. You were almost sure that this was going to be coming yesterday. We talked about linear inequalities, and that's what today's 3-minute review is all about. Now, this 3-minute review, hopefully you've got these all tried, and I'll take them up very shortly, but I am going to sort of over answer these, and we're going to see a couple of extra ways that we might approach solving a linear equation. That's going to lead us, linear inequality like these ones, and that'll lead us into polynomial inequalities. But for now, what are we doing here? Well, we just kind of solve these like a linear equation, right? I can add 2 to both sides, so this becomes 3x is less than 9, and I don't have to switch the direction of the signs because I'm not multiplying or dividing by negative. Divide by 3, and I get my answer x is less than 3 on a number line. Try and do this fairly quickly because we do have a long lesson today, so strap yourself in, folks. Draw the solution set on a number line. If we just have x is 3, that's the cutoff spot. We don't want to include it because there's no less than or equal to, and it's everything less than that. So there it is on a number line. Dandy. You want to put another point on there, you go right ahead. And here, again, we want to get all the x's on one side and numbers on the other, just like it was a grade 9 linear equation, but this is a linear inequality. I think the first thing that I would do was to kill the fractions, right? We didn't like fractions then. We don't like it now, so I'm going to multiply everything by 3. And there are different ways to solve equations. I realize that you might not have done that it this way, and that's fine. Notice that when you multiply everything by 3, you have to multiply each of the other pieces. Make sure you multiply your -2 and 2 by 3 to get that equation right there. You may have made that mistake. The next thing, I'm going to move this way and this way. So I get 4x is greater than or equal to, again, I haven't multiplied or divided by a negative, so I don't have to change the direction of the sign. Dividing by 3 on both sides, x is greater than or equal to -3, and on a number line, easy peasy, right? Here we go, here we go, here we go. There's -3 and everything greater than or equal to it. That means we want to include 3 and everything that's on this side as well. -3 and everything that's on this side. Okay, great. And so there's the solutions. Now, I'm going to mention sort of a couple of different ways to approach that. Up until this point, this is all I expect you to do. Now I want to think of it in these same questions that we already know the answer to in a slightly different way. And you're welcome to take this down, but it will show up in the lesson today as well. So you can take down these examples or just absorb them. That's up to you. It says solve, draw the solution set on a number line. Remember, a solution is anything that makes this true. And this is sort of where we began thinking about inequalities yesterday, was this idea of what values make the equation true. So I might try, well, let's try a value over here, what I call a test point. Let's try a test point of x is -2, and on the left side and the right side, then I put in the -2, and I get 3 times -2 minus 2, and the left side is -8. The right side is just 7, and the question is the left side less than the right side? Because we're interested in less than. Is the left side less than the right side? It is. So that means -2 must be a solution to our equation. Now let's try a different point. Let's try x equals 5 and do a left side, right side, and see if x equals 5 is a solution to this equation. And I get the left side and the right side. 3 times 5 is 15 minus 2 is 13, and 7. The left side is not less than the right side. So 5 is not a solution. Well, we're going to be here for a while if we take this approach. So what's the point here? Well, we know there are solutions at -2, and we know there are non-solutions at 5. But probably what this means is the numbers that are close to -2, like in here, these are probably solutions as well. And the ones that are close to 5 are not solutions. So 4 is probably not a solution since 5 is not a solution. And so somewhere in here we know there's going to be where the solutions run into the non-solutions. Where's the cutoff? The cutoff between solutions and non-solutions occurs between solutions and non-solutions occurs when this is equal, right? Where is it less than? Where is it not less than? Well, where it's equal is where it's going to go from being a solution to a non-solution. When the left side is equal to the right side, i.e., the equation. So the whole idea that we could do, instead of trying all of these test points, is figure out where the cutoff is first. So the idea is, let's find the cutoff. Where is it equal to? Well, at 3, and we know 3 is not a solution. And then we already know that -2 was a solution, so it means everything up to, but not including, the cutoff point is going to be a solution. And anything on the other side of the cutoff point is not going to be a solution. And this is the test point method. So therefore, the solution set, well, it's what we expected it to be before, x is less than 3. But let me show you how this works. It's kind of a different, nice way. How we solve an inequality then is to solve the related equation first. Solve related equation first. Bear with me. I know it's weird because it was easy yesterday. This seems more difficult. Well, bear with me. All right, so the idea, I'm going to solve the related equation first. What's the related equation? Equal to, and I'm going to solve it the exact same way, kill the fractions. Say, well, hang on, isn't this just exactly what you did up there? Well, a little bit, except for if I'm solving the related equation, I don't have to worry about changing the signs, right? So I get the cutoff is -3. So now what I do? I draw my number line, and I know that the cutoff between solutions and non-solutions is at -3. And I know that since the original equation was greater than or equal to, that's a solution. The question is this over here all shaded in or not? And same thing on the other side. So what we do is we try a test point. A test point over here might be something like, well, is -5 a solution to this? On the left side is 2 times -5 plus 2, and that's -10 plus 2 is -8, where the right side is 2/3 of -5. And I see that was kind of a stupid pick on my part because I should have made the math easy. But what do I got? I got -10/3, which is -3 1/3, is -5 1/3. And so is the left side greater than or equal to the right side? Left side greater than or equal to the right side? No, that's smaller, right? So this is not true. So -5 is not a solution. And right there, we should know that this part over here would be our solutions. But let's try a test point over here. My favorite test point is x equals 0. I love using the test point x equals 0 because the arithmetic is usually easy, right? 2 times 0 plus 2 is 2. And the right side is 2/3 of 0 minus 2 is -2. So now is the left side greater than or equal to the right side? Yes, because 2 is greater than or equal to negative 2. So this is a solution, and I know that all of these are solutions. So, well, okay, dandy. This is um, a way to approach these linear inequalities, but what was wrong with the way that we did yesterday? This seemed just way easier. Well, I'm setting you up, aren't I? This is a second way to do it that we're going to see we'll use quite extensively once we get into solving polynomial inequalities. All right, so dandy, there's the solution set for this one a second way. Now, are you ready for a third technique? And this will be another technique that we'll see is worthwhile. Method 3, and again, if you want to get all this down, you'll have to press pause and do your own graphs. This idea of graphical solutions, what we saw using a graph, TI-83, decimals, graphing calculator, whatever, is a nice way to solve polynomial inequalities. What about linear inequalities? Well, notice what I've done here. I've graphed the left side, which is this red line. Y-intercept is negative 2, then up 3, right 1, up 3, right 1, and there's the left side. And then I graph the right side, which is just a constant equation, a constant function, y equals 7, right? Slope is 0, y-intercept is 7. And what are the solutions then? Well, the solutions are the x values where the left side, or the red equation, is less than the green equation. So for what values is the red function underneath less than the green function? Well, there's where they're equal. That's the x value where they're equal. So that's kind of, and this is kind of like the number line. So that's where they're equal to. Of course, that's not a solution. So I'm going to erase that. That's not a solution. But where else is the red equation underneath? Well, for x equals 2, I see the red ones underneath, and x equals 1, and so on, everything this way. And so graphically, I could solve this. It's not where they're equal to, but it's where the red one is underneath the green one. And I can see it from the graph. The solution is x is less than 3, which is now the third technique for doing this. So how this worked from scratch. So I'm going to do this from scratch now. Maybe we'll do this one together. Set up a grid here. A little bit of scale action. And I'm going to do it using my two different colors. My left, and it doesn't matter what color you use. You don't even have to use colors. But my left side, I'm going to graph y equals 2x plus 2, a y-intercept of 2, slope is 2, so that's up 2, right 1, up 2, right 1, up 2, right 1. And if I wanted to go this way, instead of up 2, right 1, it's down 2, left 1, down 2, left 1, down 2, left 1, and I can get my equation there, my line, rather. All right, let me fix this up so it's in red and looks beautiful. All right, come on, you. There we are, red. Dandy. And then my right side, I'm going to do in green again, is 2/3 x minus 2. So minus 2, and then the slope is 2/3 up 2, right 3, up 2, right 3, and so on. And if I have to go the other way, it's down 2, left 3. There's my cutoff spot. I see down 2, left 3. And then this line right there, make it green and beautiful. And from the graph, then I'm looking for spots where the left side, the red one, is greater than or equal to the right side. So for what x values do I have the red one above the green one? Well, let me think about that. Certainly I can see where they're equal, right? That's where they cross. And equal to is a solution, so I can see there the red one is above the green one. Where else? I'm pretty certain that after that cutoff spot, the red one is above the green one. You see there? red one's higher than green, red is higher than green, red is higher than green, where on this side, the green one's higher. So that means what x values do I want? Everything to the right of x is -3. Okay, dandy. Now you've just solved two different ways that were more confusing than the easy way we learned yesterday. How does this possibly help us, Restall? You're leading us down a dark and scary path here. Well, bear with me, folks. This will bear fruit once we get to the lesson in part 2.